Hello and welcome. In this video, we are going to look at the topic of empirical formula, which for most students coming into IB chemistry is quite a familiar topic because you know exactly how to go about solving problems involving the empirical formula. But the question to ask yourself is, what's the point of finding the empirical formula? Who wants to know about the empirical formula and why? What does the word empirical actually mean? The word empirical means based on evidence or observation. And with the empirical formula, what we do is we take typically organic compounds, most often organic compounds that contain carbon, hydrogen, sometimes oxygen, and we analyze them. But the analytical methods that we traditionally would have had over the years were not able to identify the specific numbers of carbon, hydrogen, oxygen, or whatever elements. What these analytical methods usually do is they give you the percentage of carbon and the percentage of hydrogen, let's say, in the case like this question here, where it says that a hydrocarbon is analyzed and it has 85.7% carbon and 14.3% hydrogen. Determine its empirical formula. You see, this analysis gives you this data and other data, other empirical evidence that you can get. So here in this question, we are doing these two things. First, finding the empirical formula, and then using the molecular mass of the hydrocarbon to solve for its molecular formula. So we would know its molecular mass because that can be determined empirically. We can determine this empirically or experimentally. Then using this, we find the empirical formula and we work along with the molecular mass to figure out the molecular formula. So how do you go about doing that? To do that, we take each percentage composition. So 85.7% carbon is divided by the relative atomic mass of carbon. 14.3%, which is the hydrogen, both of these adding up to 100. That 14.3% divided by 1.01, the relative atomic mass of hydrogen. This answer comes to 7.13, this to 14.13. A formula cannot have decimal places or fractions, so we've got to reduce this to the simplest whole number ratio, dividing each by the smallest or the smaller of the two. 7.13 is divided by 7.13, 14.3 is divided by 7.13. That comes to 1 is to 2.005, which is very much 1 to 2. Using that ratio, we can then say that the empirical formula of the hydrocarbon is C1H2, which could be written simply as CH2. Then, what is the molecular formula of this hydrocarbon? Well, we need to be given its molecular mass. And if we're given its molecular mass, then we can do this. Divide its molar or its molecular mass, which is given as 70.15, by what we refer to as the empirical formula mass, or C1H2 all added up. And that comes to 14.03. So, dividing the actual molecular mass by the empirical formula mass, we see that it's 5 times greater. So it means that this entity C1H2 needs to be multiplied by 5 to get the actual molecular formula for the hydrocarbon that we are analyzing. And 1 multiplied by 5 is 5, and 2 multiplied by 5 is 10. So C5H10, therefore, is the molecular formula of the hydrocarbon that we are analyzing based on percentage composition. That's the empirical evidence, percentage composition and its molecular mass or its molar mass. What we are using these two pieces of empirical evidence to do is to determine its molecular formula. And this is the purpose of doing calculations involving empirical formula. Now I would like you to do this question.